right, my name is Jack Rudloe. I'm the president of Gulf Specimen Marine Laboratory in Panacea, Florida. And I want to welcome you to this little session on the electric ray. Well, it's actually electric fishes, but we're going to mostly concentrate on the ray. This is sort of the same group of stingrays and cownose rays and eagle rays and all the other rays, but this one particular creature has evolved electric organs, and it's able to defend itself and seek its prey out and communicate using these electric organs. And this particular creature likes to bury down into the sand. So I'm hoping we can show you, I don't know if we can see this or not, but right now he's buried over here. Let's see if you can manipulate this down where people can see it. So here's a little box. All right, I'm going to have to bury it. What I'm doing is I'm moving him slowly, trying not to get shocked out of the sand, and maybe he'll burrow again. Can you see him now? Okay. And he's a pretty little creature that has intricate markings on his back, and he will also, if we annoy him, give an electric shock. And I have been shocked by many of these things, but I'm hoping he won't shock me right now. So far, well, he did a little bit. And if I squeeze him, then he'll really let me have it. Okay. But right now, he's just swimming around, and I hope we can see him here. Anyway, so this is the lesser electric rays, Narcine brasiliensis. And what he will do is he will burrow down into the sand, hide. So imagine when he's about this big, and you're a recreational fisherman casting into the surf, and you're walking along the tide flats of Alligator Point or Indian Pass or any of these barrier beaches, and all of a sudden you step down and you don't know anything except you're walking on sand, and you feel this tremendous jolt run through your body. And what you have done is stepped on an electric ray, except that you'll never put that in perspective because you probably won't see him. So you'll think a shark just came and took your leg off, but it isn't. It's just a shock that comes through from this fish, which is minding his own business in the sand, and he's very entitled. He knows that nobody's going to mess with him, but here comes this foot down on top of him, and whack. So anyway, there it is. Anyway, we're going to talk about electric fishes, so I'm going to slide this out of the way. Pardon our housekeeping here for a minute. And we will show a couple of other things here. One of the things I want to show, oops, did it get lopsided here? Yeah. This is the group called Torpedo Rays. Can you see this? All right. This is in the old school of natural, I don't think we're seeing it. Okay, yeah. This is a mount that was done by Carolina Biological, but it was actually done in England, and it's probably about 60 years old, and this is a torpedo ray. And you can see that it's very well dissected. It shows the electric organs. Once upon a time, with these meticulous old biologists and technicians, all the little labels are fallen off or on the bottom, but it also shows the neurobiology. It shows the brain of the electric ray and the spinal column and all the nerves that branched out. So that was in the days when the very intricate science was done, long before, before photography and before all the other stuff that came along. So we don't do this sort of artistic stuff anymore, and that's really the stuff that I had learned to do. Okay, so now we're going to talk about the PowerPoint. All right, so now this advances it. Yes. Actually, this is a picture of an article that we did in the Smithsonian magazine that you can check out on our website, and it was about electric fishes. So let's talk about what are electric fishes here. And essentially what we've got are three different types. And we have the strongly electric fishes, just like the electric ray, but the most powerful of them all is the electric eel in South America, which, by the way, is not really an eel at all. It's a giant goby. But those live in the marshy rivers and the muddy swamps and everything else like that. And they give about 600 volts. So if you ever step on an electric eel or grab one, it's really no fun. I've been zapped by a couple, and they certainly do wake you up. Well, next to that is the electric catfish in Africa, and that's another strongly electric creature that you don't want to particularly lay your hands on when you catch them in the net. And then we have another creature called an electric stargazer around here, which is an extremely interesting creature. You almost never see them. They bury in the sand. They don't put out much of a shock, but their electrical shock that they do put out, which is just a volt or two, is extremely powerful, and it can even separate the vertebrae of, like an anchovy, part of their prey. So that's the strong sharking fish, the electric eel ray we're going to talk about as part of it. Then there's the weakly electric fishes. Some of these are shown, like the knife fishes and some of the elephant fishes. These are basically, they don't put out a big charge, but they put out a tiny little electric pulse, which they use to communicate with each other. So they have a whole language of click, 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 beep, 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 and all that sort of thing, and they can speak over long distances in turbid water, and they emit electrical powers. And then we have the much more abundant, commonly known electrically sensitive species, like all the sharks, all the rays, all the chimerans, and even skates and catfish all have these electrosensory organs, in the case of the sharks and rays, called ampullae of Lorenzini, which are little jellyfish pits that pick out, boom, they pick up the slightest contraction of muscle of, say, a buried flounder or a stingray, and a hammerhead shark swimming over, 20 feet above it can pick up this micro pulse with his little sensory organisms and home in on it and grab the prey and go crunch. Okay, so those are, but we're focusing on the electric fishes. This, by the way, is the electric stargazer, and that's really quite an extraordinary fish right here, because we can't make this bigger on the screen, can we? It's not, no. Okay, anyway, he buries completely in the sand. His electric organs are on the top of his eyes, and his optic nerve is expanded into there, right? And like I say, you would almost never see this fish. You catch them in shrimp nets or in beach seines once in a great while. They're full of spots. They're really interesting looking creatures. And if you actually touch one, you won't likely get any kind of electric shock that you can feel. But, a good example is my son, Sky Rudloe, years and years ago, was keeping the lab here, and there was a big pet electric stargazer, so he was feeding him by hand, and the stargazer jumped up and grabbed his finger instead of the fish, and it just about knocked him down. He had a splitting headache. He had to go home. This is only 1 volt that this thing is able to do, so we call this a magic biological electricity. The skates, on the other hand, which is this guy, these things don't have direct electric organs, but their tails have a little minor electric organ which they use for communication, so they can stay together in school, and they give out little micro pulses, which is very interesting that they can do that in salt water, because salt water is not a very good conductor of electricity, but nevertheless the skates have some power to do that. So there's a great deal of mystery in these electric fishes. Okay, so now we go on, and here is our pet, the electric ray. Now, they have electric organs in here, which we'll see in a minute in the dissected stuff, that dissected specimens that have special organs in them, or special structures of cells and prisms that can carry off the voltage and give you a good rattling electric shock. Usually, it's all located up here. So if you grab them by the tail, they don't do anything here, but they won't be able to shock you particularly. But if you pick them up by the tail, they're very good about twisting around, connecting their head with your hand, and jolting your teeth. So you don't want to do that very much. Now, what we're going to be really talking about is, in this particular creature that I'm particularly interested in, is there's this little area over here, and there are these 2 tiny little holes called endolymphatic ducts. And it is these that go down to the, what did I do? Okay. These go down into their skulls, and that's where they seek out, that's where they bring magnetic sand grains and other heavy minerals down into their skull. Why they do that, that's a mystery, and we'll be talking about that. So this is a presentation that years ago Anne Rudloe, my late wife, and I gave to DARPA in California. I forget the town anyway. And we were trying to convince them through funding that this is the ultimate creature, that in San Jose, that this is the creature that they should really be looking at. It never happened because they said, okay, fascinating, but what did these things do? So we haven't answered the questions and never will be able to unless somebody puts some serious funding into it. But this is my argument to convince that it is worth it. Okay, where do you find electric rays? Well, here's the story behind this. Years ago, back in the very early 80s, like 81 or 2, I got a call from this researcher, Dr. Robert Johnson, up in the Boston City Hospital, and he said, we'd like to buy some electric rays. And I said, yeah, you and everybody else, they're hard to come by. He says, no, we want to get a regular supply of electric rays. We would like to have, 10 animals shipped to us every 2 weeks, totally dependable and everything else. And he says, what would that take? And I said, about $100,000, maybe more, He says, oh, and I said, that's a call I've had to make before, and then you sort of give the price of what it would really take, and they go away, but not this case. So a little while later, he calls back and says he's with Howard Hughes Medical Institute, and he says, can you do it for $80,000? And I thought for a minute, well, being very hungry at the time, and wow, excited and everything else, and I says, yes, we could do it. And of course, in the next 3 years, I had cursed myself many times over and wished that I had stuck at least to those guns, because it turned out to be a much more expensive project than we ever did. But we did indeed turn the electric ray into the laboratory mouse. So these are some of the stations and some of the areas. We chartered a shrimp boat that was usually at about $1,000 a shot to go out there for 24 hours and beat out and drop the nets down and look for electric rays. And nobody really had ever tracked them or looked for them. They know they get them in their nets, and there are no certain areas, like off Alligator Point is really a good one. And okay, oops, we did it. Are they getting to see all that? Okay. Alligator Point was one area here, and an area called Mud Cove, and then there's some off Dog Island on the East Pass that comes out, but they really like river drainages. Like this is the Ochlockonee River, and all this freshwater swamp and minerals and everything else comes out into the area. So this is an area electric rays would like. Dog Island, a little bit on the east end. Most of it on St. George is on the west end, and this is called West Pass. This is the mother lode. Okay, we can do that. Whoops, what happened? Okay, this is the mother lode of where they're really at. This is giving me problems. Okay, so the area right off here, this is the St. Joe Peninsula, Indian Pass. All of these areas are hot spots, particularly over this way, for electric rays. So we would beat out there with a shrimp boat, drag the nets, catch them, bring them back alive, and you will see some of that in a second. This is the distribution that we caught. Over the course of the project here, which was, this shows a year, but it was about 3,000 rays that we caught. Most of them we tagged and released to learn their distributions, but the rest we basically tried to keep alive, had to learn how to keep them, how to feed them, and then ship them regularly up to the Howard Hughes Medical Institute. It was first in Boston, then later moved to Philadelphia, but it was a consistent project of which they were learning to map the neurotransmitters that electric rays have in order to deliver a resounding electric shock. It's acetylcholine, which is the synapses chemical between the nerves, that this thing can build up in large quantities, and more so than anything that we can do in our tissues, because we just can't give electric shocks like Dr. Spock, that we will talk about later. Okay. So its potential of where it lives and what it does, I'm not going to really dwell on this very long, but we found that the barrier beaches is a nursery habitat. We found that the rays would come in when they would mate, when they would give birth to live young. how they ate their food. We looked at gut contents. We found that they basically ate worms. They loved worms and eels, and they found worms that, you know, I might see one or two in a whole year of digging around on the flats, and their guts would be packed with them. So they really know how to catch it. So what they do is they essentially see the worm, bite the head, give it a violent electric shock, and yank it out of its burrow like it's a limp piece of spaghetti. Pretty interesting stuff. Now, you learn little things like that. So this is on the scene on a shrimp boat. Okay, this little electric ray I showed you just a little while ago is typical. Sometimes we'd get, you know, 30 or 40 of them on the deck from all the different rays that we're catching, and they're intern juveniles. So when you go on a shrimp boat, you have all this bycatch up there. You know, actually 10% of the shrimp you eat of the bycatch is 15% of the shrimp. The rest of it is croakers and butterfish and catfish and sea robins and all kinds of crabs and stuff like that. So you call that overboard. None of it is wasted. There's happy fish, dolphins, and lots of sharks under the right conditions ready to gobble them up. But also the sky is boiling with seagulls. And so the birds are diving and the pelicans are thrashing down, gobbling up the stuff as fast as it comes off the shrimp boat. Well, guess what? Here goes the baby electric rays back, and they're swimming on the surface. And here's the seagulls hovering around, squonking, screeching. Now these are like 10, 15 feet up in the sky, looking at these little morsels swimming off and not dare going down to touch them. Now, how does that work? Can anybody tell me out there? How can this fish in the water that stays buried in the sand speak to birds through the air and advise them that they really don't particularly want to go eat them? Because they never did. In all the hundreds of rays that we put back and all the seagulls, we never, ever, one single time saw a seagull dive down and grab a ray. Now, tonguefish, hog chokers, small croakers, all of those types of things, the birds went crazy grabbing it up. Not the electric ray. Not a bit. Not any time. How did that work? Okay. Then the sharks. That was always fun. So we go off West Pass, and we got a deck load of stuff, and we're culling it overboard, and the sharks come roaring up there and grabbing it and gobbling it up. You've got black tips and bull sharks and lemon sharks sometimes. It's hard to say, but you know that you don't want to fall overboard with all this feeding frenzy going on, and then gobble, gobble, gobble. So you throw a stingray overboard, and snam, it's just gone. Throw a skate overboard, up comes a shark, grabs it. Throw an electric ray overboard, and you can actually see the shark. I've seen this a couple of times. I wish it had it on video. And the shark comes up, the jaws open, it gets within a few inches of the ray, and then bolts away, fades off, and everything else. So the ray is a Star Wars thing. The ray detects the shark missile coming at it, fires a blast, and it goes away. And you know, we've seen this happen again and again and again. So sharks stay away from electric rays because their ampullae of Lorenzini, the little receptor organs that we talked about, are very, very sensitive to little muscles of, you know, contractions of fish and vibrations in the water. And here it gets whacked with a bunch of stuff. Well, while I'm on this subject, I have to tell you this little story. Okay, when we made this presentation in Panama City to the Naval Coastal Systems Laboratory, and we had all these big Navy SEALs and tough guys there, and we had some live electric rays, and I said, you know, you want to touch them? And no, they were scared of them, so they. Anyway, we had our presentation, we talked about it, and we went out to lunch, and we went to a little seaside restaurant. Well, this poor big female ray that I had, we trucked her around, we had an aerator on her, and we, you know, it was just wore out, basically. So I said, okay, she needs to go free. So I couldn't go to the Barrier Beach, so we were just going to turn her loose in St. Andrews Bay. So we got into this restaurant, it's got a little dock there. So we walk out on the dock, and I'm about to turn her loose. And I look down there, and there's swarms of pinfish. I mean, there must have been 200 pinfish that are used to eating anything and everybody that fell overboard. You know, I mean, it was just, they're just ravenous little monsters. And I'm thinking, and these guys are from the Navy with us, and I'm thinking, oh my God, this is going to embarrass me. I'm going to throw this ray over, turn it loose there, and they're going to tear it to pieces. So as soon as I do, I put the ray in there, and the fish advance right before it. You can see down in clear water, and they come swarming up to the ray. And then all of a sudden, and you don't see anything, but all of a sudden the fish back up real quick. And then as this ray waddles off, I mean, anyway, by the way, they're a very slow swimmer. Anybody here can outswim an electric ray because they don't need to swim. They just waddle off, you know, and they could care less. And here's these pinfish, this big school of pinfish following this thing out to deeper water, keeping about 3 feet behind it. So, is this not an organism that the Navy or someone should be interested in? Is this something that we should be looking at? You know, of course it is, but this is not the way people think. They want an instant answer without doing the research. So how does this thing work? Okay, so here's an example here, a drawing of where you can see the electric organs over here. And they have these little hexagonal plates which are prisms. And this is sort of a shot of here, and each of these prisms in this thing is like a stack of what do they call them? They're electroplaque crystals, essentially, or prisms. And each one of these little things generates 1/10 of a volt in the cell, and it keeps building, 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 and you get 1 cell, 1 volt, and then the whole thing collectively picks up, and it sends off a shock where something that might be this size could give you 80 to 100, 120 volts. And believe me, if you get that, you don't want to continue messing with them. So, so this is the functioning, and in order to do this, all of these nerve synapses, these giant synapses there, carry carry the voltage out. And then this is the brain, and then we're going to talk about the brain stem, which is the weirdest thing in the world as far as I can think. I'll tell you about that. Anyway, this is sand grains, all right? These are sand grains that are just like what we just saw the ray burrow in. It is all quartz grains, and they're made out of clear quartz. 1/10 of 1% of all the grains out there in a handful might be a heavy mineral. It might be magnetite or titanium or a zircon or garnet or a sphene or something like that. Extremely rare. Now, the ray has this ability to collect it. Now, where you find it in a tide flat, one of the places you find that little bit of that heavy minerals is when you have ridges. So basically, they're heavier than the rest of the sand. So what happens? This is all quartz up here, and the stuff that sloughs down into the canals can be magnetite or some of the other heavy minerals. That may be what it is, but this isn't all magnetite. This is other particles that are other things, and mud and detritus that are in there. But that's kind of where you would find that. Okay, now we're back to the magic here. This is the electric ray again, and these are the endolymphatic ducts, the tubes that go down into the head. They're here, and you can see them even on that little ray or whatever. Now, mind you, when these things are born and they pop out of mama, they have nothing in their sacculus. Their sacculus is absolutely empty. From the time they get out and they start swimming around, that's when they start getting interested in sand. Okay, so we're going to look at some of this. Now we've cut away the skull and the skin. So what we're looking at here to begin with, this is the electric organ and the actual tissue at the prism. It's very mushy, and it's just actually, if you decide to cook and eat an electric ray, that's the only part that isn't really edible. The rest of it is not bad. I've eaten several electric rays. Okay, but the interesting thing is the sacculus. So this is here's a hole, the sacculus that goes to those little pits, and here's that has just the top is cut away. This is cut away a little deeper. And over here you can see the minerals and the magnetite down inside the skull. The skull has been shaved away. And what I really want to show you is this part. We'll eventually get some better pictures, but not today, really. This is the brainstem. They have an orange brainstem. I don't care what you find in the animal kingdom or what you look at, an ape, a chimpanzee, an aardvark, a fish, any other ray, they do not have orange brainsstems. And the only place you find the orange brainstem is in the electric ray, underneath, basically in between the ducts that contain the magnetite and the other material. Wouldn't we like to know what that's all about? Now, mind you, I have explained this and shown this to many scientists, and they act like it's science fiction. They back away. They don't want to understand it. They get very confused. I'm very happy to see that Gavin Naylor, we have a video on, he came up and just got an electric ray, is the only other human I've found yet who really wants to help tackle the problem. So we're going to be doing it. So I'm very excited about that. But anyway, most of the time, this is what we get. And you can look at it a little bit better here. It's just a tiny blob, about a millimeter, a couple of millimeters. It's a sac. This is all contained in a mucus sac, and that's where all those minerals are. So here we've got it. We might have broken up some of the others, but this is largely a bag over here that leads down. Oh, and here's a better shot of the brainstem right now. And you can see here's the sacculus, and here's the sacculus, and here's this weird orange brainstem. And this is covered over with some tissue, but when you really look at it and dissect it, it's two perfect lobes, and that connects to the spinal cord. Okay, so here's the actual blow up of it with they call it exogenous mineral grains in the sacculus, is what it's sort of described. And again, you can mostly see quartz, but a lot of this is magnetite, and sometimes it'll actually line itself up in a barber chair spiral. This is a kind of broken up one, but I have seen some in there that look exactly like a barber chair, like a barbershop spiral, which makes it pretty extraordinary. Look at it under an X-ray, and here's what you see. This is all tissue, but there is the minerals, and they show up that way. And these are some of the minerals, all right? This isn't really the best shot, but this is probably magnetite. But what's really interesting is these long things are zircons. And now and then we can get a ray that actually has a head full of perfect zircons. And that means they're pointed on both ends. And I brought them some to a petrologist at FSU, and they looked at this stuff under the scope, and I explained what it was. I showed them the thing in the skull, and they said, finally we had this long conversation. They're looking at it under the scope and says, it's gorgeous, zircons. Where did they come from? And I said, what? I mean, what I've been talking about. He says, well, we find that hard to believe it really came out of this was sand grains in the ocean because this was so perfectly polished. Later on, I've heard that possibly under electricity, zircons can actually grow. So these were absolutely perfected, and they're also in this thing's skull. A lot more work needs to be done with that. And we had Dr. Joe Donoghue from the Geology department doing an analysis. At one point, I had to come up with a gram of electric ray minerals, which was a major job of boiling lots of rays and skulls and everything else to get that. And he looked at a spectrum of all the different materials that were in there. Now we could do it, it's much more sophisticated and could do this with a lot less, and would love to go back to it. But we don't have Howard Hughes kind of backing it in the background. But this is a garnet, almost like a ruby, and these are some of the other crystals that were found with scanning electron microscopes of zircon pieces. And under the garnets, this is the electromagnetic field that a garnet produces. So this guy is sitting there finding all these strange things. What am I doing? I go backwards? Nope. All right, so anyway, where do you find magnetite in creatures? Well, we have biogenic magnetite, and sea turtles are a good example. They have these little magnetic crystals in their skulls, basically in their nostrils, the dermathoid region of the bone of the brain, and these are able to use those in their magnetic orientation. So do sharks, so do whales, so do butterflies. And look what these are. These are these little perfect submicroscopic crystals that are made by the animals themselves. That's why we call them biogenic magnetite. And 30 angstroms is incredibly small. It's about as small as you can possibly get and still be a magnet with two poles, a north pole and a south pole. But the electric ray is a different critter. That is the one that basically mines exogenous grains and packs it down in its head. So just as we began this thing showing you a buried electric ray here, down in there under the sand, and here he is up on the surface, that's what they do, and that's what I was hoping over the years that we can get somebody else to do. Now, let me tell you why this is important. Okay, well, they have this business of being, they could be a good study for underwater vertical orientation, underwater communications. The rays will actually talk to each other with little clicks of shocking. They can also do electric defense. This was all the DARPA thing, but this was the. Why are we not seeing the whole thing? Oh, here we go. All right, so let's look at the future. I mean, are we going to be powering our cars and housings and buildings with electric rays? Well, who knows? But here is a torpedo ray from deep water, and here is the Starship Enterprise. Okay, you see there's kind of a similarity between that, the disk, and so on and so forth. And here is Captain Kirk with Mr. Spock, and they are looking at the dilithium crystals right here. Whoops, get me back. Okay, they're looking at the dilithium crystals which power the Starship Enterprise. So if we were to really look at the electric ray, I can't say we're going to power the Starship Enterprise, but we have a totally unique organism unto the planet Earth with a different anatomy, with all the potentials of learning a lot more about it. And that's one of the things I'm very proud about Gulf Specimen that we've been able to do. We've had many accomplishments over the years, but our work with the electric rays, the publications that Anne Rudloe did, if you go to our scientific publications under the About Us section of our website, her papers describing all of these, some of these were her graphs and charts, and how we learned to keep them, and all of that stuff is in there. And also my book, The Wilderness Coast, has several chapters on the electric rays and the sagas of trying to get live worms to feed them, and adventures of getting stranded out on tide flats and almost drowning. And anyway, we'll go on and on. But the electric ray still remains, and I'm very much hopeful that we can continue to develop this and especially look to the future of the Starship Enterprise and powering our world and solving our energy crisis. So thank you very much. Any questions?
Well, how does it feel to be shocked by one?
Well, sometimes it feels like you stick your finger into an into a light bulb socket. You can experience something like it, but it's still very different.
Is it strong?
Depending on the size of the ray, it's a little ray over there, you would just get a tingle. A big ray, and a big ray that's really angry at you, being for bothering it, yes, you get a substantial shock.
Has anyone died from it?
I've never heard of anybody dying from an electric ray. I've heard about somebody supposedly dying from electric eels, but not from an electric ray that I know about. I will say that I've talked to a lot of people, like there's divers in California. They have a much bigger electric ray than we do. They call it the Torpedo. And they say that they don't eat worms. They can actually catch a fish in mid-water and shock it to death, wrap their arms, wrap their body around it, and then give it a jolt. But there was a group that was studying them out of one of the California institutes. Anyway, basically, they had one diver there that knew when the electric rays were coming because he could feel them in his teeth. Because he had a feeling that was there. So when they were all sitting there looking and say, where are the rays? They couldn't, and all of a sudden, this guy would feel a tingle, and he'd say they're coming, and they would come. So who knows what the distance is.
Which book were you talking about with the electric ray?
It's called The Wilderness Coast, and it has the main chapters, Night of the Electric Ray, and then Tide or something of the Plumed Worm. Basically, the plumed worm was when I walked out on a tide flat. Oh, they would only eat worms, so we had a heck of a time learning where to get worms to feed them. Eventually, we settled on the Maine Bait Company, and then there was the Tampa Bay Lugworm Company that was supplying sea worms. But anyway, until then, I had to dig up worms on the tide flats. And one night I was out there, way out on the tide flat in the winter, and I was digging up the worms, and the tide changed very abruptly and came in, and a fog came down, and I couldn't see which way I was going. So if I went in the wrong way, and I would have drowned. froze and all that. And fortunately, I picked the right way. That was just sheer luck. So it got to be a pretty risky business. For many risky, it's the only time I've ever had a tree fall on me out in 20 miles offshore, because during after a hurricane, we caught this big pine tree, lifted it all the way up to the top of the bone, and then it broke loose and came down and brushed me with the branches and all that stuff. So I thought it would be interesting to get killed by a tree out in the middle of the ocean, but it didn't happen, thank God.
Okay, we have a question from Aaron Clevenger.
Okay.
He asks, do rays have cerebral spinal fluid covering their brain? Do the shocks you feel come directly from specialized neurons?
That's a very good question. Certainly the brain, like us, has a spinal fluid around it. I mean, any living thing like that. As I say, the magnetite sacs, for one of the ways, certainly has some gooey stuff that's in there as well. But I think the real shock really comes from the electric organs building up, transmitting all the way to the skin of the fish, and then from the skin to you. But I don't really know how the mechanism works.
Does anyone know how it works?
Not really. They probably, it can be argued either way. It's almost a question of physics as much as well as, this is what I wanted DARPA to go ahead and fund, or somebody to fund, or something where we could be asking. I envisioned once upon a time that FSU Marine Lab and Gulf Specimen could work together. That was a nice fantasy because, Woods Hole Marine Biological Laboratory and Woods Hole Oceanographic and that center up there, which I had worked and everything else, had a place for scientists to work, and then they had a collecting facility called the Supply Department. And they would go out and get the stuff and work with the scientists, and the scientists would come to get squid and other things of that sort. And I sort of thought at one point when I was naive that, maybe there's a way to work with the Marine Lab and we could do that, and we could create a wonderful science center here along the coast. But that never happened. So anyway, I hope someday we will be able to get a center going for electric rays, because there is no better place in the United States to get them than right here in the Florida Panhandle.
They're not endangered.
They're not endangered. No, they're not endangered.
We have a question from Isabella Rizzo. Could further understanding of this mechanism potentially be used as a controlled predator deterrent?
Yeah, well, sure. But they're doing it right now. There are lots of shark repellents that are based on electric charges, and they give out a microvolt thing, and it's not right, and your predator goes away. And those are, from what I understand, divers use them, and they're pretty effective. Divers do two things. They'll use that, or they'll actually have a face of a great big bunch of eyes on the back of their scuba tanks or whatever else it is that look like something with big eyes and teeth that's going to bite back. So, visual is still part of it, but electrosensitivity is certainly a realistic part.
Oh, we haven't showed the skull yet.
The skull. We got to do the skull, right?
Is it this one?
Yeah, right. Okay.
Let's see.
All right. Yes. Now I have to show you. This is. All right. Allison's going to light this thing up for you. Anyway. So I have taken things like this skull up to Bar Harbor and places in Maine where they actually did a great deal of work with sharks and rays, and they were placed. And I was trying to explain that these things, kooky fish, stick rocks in their heads, and they weren't particularly believed. So I learned that I could take this thing and show it to them, in addition to this dissection and this PowerPoint. But here you can actually say this is a skull of a ray. So what you do is you boil a ray, you take the skull out, and the little dark spot right in here is the sacculus, and you can actually see the sand grains right in the head, right there. And it's kind of neat when you actually get a light in there. Eventually we're going to get a pike light in there or something and light this up.
Both ends.
And they're both, well, yeah, you have two sacculuses there. By the way, in your sacculus, I will have to say this is, you want to check your own sacculus out. It's right here behind your ears. So this is what we do, and this picks up extraordinary loud sounds or whatever. It can filter those out. And it actually can give you quite a buzz through noise like jet engines. But this is the part